Today, we're going to talk about a really radical new idea in AI. And it's not about building bigger models or just feeding them more and more data. Nope. This is about teaching machines something so fundamental to us, yet so completely alien to them: the ability to understand cause and effect.
So think about this for a second. It's kind of weird, right? We've got these incredible AIs that can write poetry, generate unbelievable art, even pass the bar exam. But if you ask that same super smart AI to just explain why a simple joke is funny, to break down the cause and effect that leads to the punchline, it just kind of short circuits. And that reveals this huge, fascinating blind spot in even our most powerful systems.
And here's the thing. Modern AI is an absolute master of association. It could look at a mountain of data and find correlations that no human ever could. But it has no idea why those things are connected. It sees that a rooster crows around sunrise, but it doesn't get that the sun causes the rooster to crow. It's stuck on the surface, just seeing patterns, without ever grasping the deep causal rules that actually run the world.
So how in the world do we fix that? Well, researchers are now looking to a pretty surprising place for inspiration. They're studying the single most powerful and efficient learning machines on the entire planet: human toddlers.
This big idea comes from the work of developmental psychologist Alison Gopnik, and what she argues is that kids aren't just these little passive sponges, soaking up information. Not at all. They are active, tireless experimenters. They are what she calls scientists in the crib, and they're constantly running little tests on reality to figure out how it all works.
And that gets us to this core concept: interactional learning. See, most AI today learns by just seeing, by passively observing huge data sets. But kids learn by doing. They poke things, they push things, they drop stuff just to see what happens. And it's that active experimentation that lets them untangle what's just a coincidence from what is a real cause.
Let me walk you through this classic experiment that shows this perfectly. It's called the Blicket detector. So in step 1, a little kid just watches. They see an adult put 2 blocks, let's call them A and B, onto a special box. And when they do, the box lights up and plays music. Now, an AI watching this would just learn a simple pattern. A plus B makes the box go.
But here's where the magic happens. The child does something a modern AI would never think to do. They don't just copy what they saw. They intervene. They get curious. They start experimenting. They put block A on the box by itself, and boom, it lights up. Then they try block B all by itself, and nothing.
And just like that, they reach their conclusion. The kid figures out the hidden rule. Block A is the special one. It's a blicket, the thing that causes the machine to turn on. Block B is just a block. You see, they went way beyond just matching a pattern. So they didn't just memorize a fact, they built a little mental model of this tiny piece of their reality. And that ability to uncover the hidden rules of the world is exactly what we need to build into our AI.
Now, there's actually a formal way to think about this whole journey to understanding. The computer scientist Judea Pearl came up with this brilliant framework he calls the ladder of causality. And it basically lays out 3 distinct levels you need to climb to get to true intelligence.
So the first rung, the bottom one, is association. That's just seeing. It's asking, what patterns are there? And this is where basically all of today's AI lives. The second rung is intervention. That's doing. That's our little scientist in the crib asking, what happens if I do this? But the third rung, well, that's the most powerful of all. It's counterfactuals. It's the ability to imagine, to ask, what would have happened if I'd done something else?
And what's so wild is that this ladder maps perfectly onto how a human kid grows up. Right from birth, we're masters of finding patterns. By the time we're 2, we're little experimenters, running around poking everything. And by 4 or 5 years old, we're asking those incredible, endless what-if questions, running these complex simulations of different realities entirely inside our heads.
So let's be really clear about where we are. Our most powerful, most sophisticated AIs are, in a causal sense, stuck on that bottom rung. They're like newborns. And the whole goal of this new wave of AI research is to figure out how to teach these machines to finally start climbing that ladder, to go from just seeing to doing, and ultimately to imagining.
Okay, let's talk about that top rung, the counterfactuals, because this is where it gets really, really interesting. It turns out that our incredible human ability to imagine what could have been is powered by one of our most complicated emotions, regret.
Seriously, just think about that for a minute. How is it even possible to learn from a path you didn't take? I mean, if you chose door number 1 and it was just okay, how can you learn that door number 2 would have been amazing? The secret is in our brain's unbelievable power to simulate.
And neuroscience actually gives us a big clue here. It turns out our brain doesn't just have one learning signal, it has at least two, and they're both driven by dopamine. The first one is the one we always hear about, the reward signal. It basically asks, did I get the treat I wanted? But there's a second, much more subtle signal that's all about pure curiosity. It asks a different question. Did the world behave the way I predicted it would? And that signal's only goal is to help us build an accurate map of reality.
And that is where regret comes in. But in this context, regret isn't just a bad feeling. It's a tool. It's an incredibly powerful learning signal. It's what happens when your brain compares the result you actually got with the simulated result you could have gotten. It literally lets you learn from the choices you never made, giving you these free lessons from imagined futures.
And the payoff for building an AI that can do this? It's huge. We're not talking about a small improvement. Researchers estimate that an AI that can learn from its regrets, from what it did and what it didn't do, could learn up to 10 times faster. That's a massive leap, letting an AI master complex tasks with way less trial and error, a lot more like a person.
So, what does all this mean for the future of AI? Well, we are talking about building a completely new kind of intelligence, one that isn't just a brilliant pattern matcher, but a genuinely curious, experimental, and even imaginative learner.
And you might be asking, why does this matter so much? Well, a causal AI would be a total game changer. It would learn way faster with a fraction of the data. It could adapt in real time if the rules of the world suddenly changed because it understands the why. It could take what it learned in one situation and apply it to a totally new one. And maybe most importantly, it would be safer and more robust because it wouldn't be fooled by random, meaningless correlations. It would actually start to understand the world in a way that's much more aligned with how we do.
Which brings us to one last pretty mind-bending thought. If we actually succeed in building an AI that can learn from a computational form of regret, we're essentially building a machine that can imagine alternate realities and compare them to its own. So, what other human experiences, what other emotions, and maybe even what kind of wisdom could possibly grow out of an ability like that? That's the question that's going to drive the whole next chapter of AI.